Time for what feels like kind of an abrupt change, but we are going to go on to fluids. This is a video about density. Density is one of the most important things that we need to understand fluids, and we give it a variable of rho. This is a Greek letter rho, lowercase. We define density as a mass divided by a volume. And so we give this units of kilograms per cubic meter. A lot of times in a chemistry class especially, you will see grams per milliliter. So we do have to be able to do some of these volume conversions. We know there are 1,000 milliliters equals 1 liter. We know 1 milliliter is 1 cubic centimeter. So we can also say 1,000 liters is 1 cubic meter. And that'll help us out a lot. A big thing that's convenient to go from grams per milliliter into kilograms per cubic meter. We can say 1 gram per milliliter is equal to, I should have moved this a little bit, is equal to 1,000 kilograms per cubic meter. This happens to be the density of water, which is the most common fluid that we work with. So density is mass over volume. It's a measure of if I've got a certain amount of this thing, a certain space taken up by this is how much weight I have, this is how much mass I have. Water has a density of, like I said, 1,000 kilograms per cubic meter, which doesn't sound, I don't know, maybe to you that sounds like a lot right away, but maybe it sounds like an abstraction. If you are standing on the ground and you have a meter stick, you know about how big that is. Meter stick, yardstick, they're about the same size, it's pretty close. So you know about how big that is. If you had enough of those to make a box, to make a cube, that cube, and you filled it with water, that cube would have a mass of 1,000 kilograms, which is 1 metric ton. This is about 2,200 pounds. We don't necessarily think about just how much water that is, but here is a video of a car encountering this kind of water. We don't think about just how strong that is, just how much mass that is, but here is a video of a car encountering this kind of water. This guy pulls up. I muted the video, there's a lot of screaming. This guy pulls up, doesn't want to wait behind anyone. So here he goes, he's going to pass him, and watch what happens to this car. Everything's okay, kind of passing through, and then carried off by that water. Water weighs a lot. We don't really think about how much water weighs because cars also weigh a lot. But that's a ton of water. That's actually literally tons of water. It makes a difference. So that's the idea of density. It's just a mass over a volume. I want to do another example. Maybe we've got this metal cube. And the metal itself is going to have a density of, let's go, 3,000 kilograms per cubic meter. And maybe we've got a cubic meter volume box, but it's pretty thin. Right, we make this thing, it's a shell of a box that's hollow inside. So then when we make this, we can fill it with whatever we like. Maybe this thing has a thickness that is, I don't know, a quarter centimeter or something like that, and so the mass of the actual metal itself works out to be 2 kilograms. Well, now we can see what happens. We have maybe half a meter in every dimension, which means we have a total volume of a half times a half times a half is an eighth, 0.125 cubic meters. We have total mass of 2 kilograms, but we also have the air that's inside this thing. Air density is 1.29 kilograms per cubic meter. So the amount of air we have in here, mass is density times volume, is going to be our 1.29 kilograms per cubic meter times our volume. And that works out to be 0.161 kilograms. We also had our 2 kilograms from the shell of metal itself, so our total mass is going to be 2 kilograms plus 0.161 kilograms equals 2.161 kilograms. Our total volume was 0.125 cubic meters, so our density total, which is mass over volume, we're going to do this, 2.161 divided by 0.125, and we get 17.3 kilograms per cubic meter. We have a shell made of metal, and our metal has a pretty high density, but because we only made a shell and then filled it with something lighter than metal, we ended up with a density of 17.3 kilograms per cubic meter, well below 1,000 kilograms per cubic meter. This metal box would float in water. Now, we haven't talked about what floats and what doesn't yet, but you do know from early science that you do, like in grade school, you do know that if something's got a density smaller than water, it's going to float in water. We'll talk about the why of that really soon. For right now, this is how we can take a material that's really heavy, that's really dense, like a metal, and make it into something that floats, like a ship. We can even load this thing with plenty of extra mass now. We can pile some masses up on top of this, and we're probably still going to be well below our threshold value of 1,000 kilograms per cubic meter. That's density.